My students, this is the part 2 of our lesson. Before we move on into this part, let's briefly go back to the previous parts so that we'll show some summary of what we did. In the last class, we made mention that H, that is, quantity of heat supplied to a body, equal mass times specific capacity times temperature change. We also went further to also say H can also be called as Cp theta. Cp means specific heat capacity, while small letter c means specific heat capacity. So from here, it means this MC is also equivalent to Cp. So you can say heat capacity which is Cp equal MC. And also, we also made mention of the units for the specific capacity and the heat capacity. We are told that small letter c, that is specific capacity, is given as joule per kilogram per Kelvin, while capital letter C is given as joule per Kelvin. And the small letter c, that is specific capacity, which is the quantity of heat required to raise the temperature of a unit mass of a body by 1 Kelvin, that is C. While capital C is the heat required to raise the temperature of the whole body of a substance by 1 Kelvin. So from here, we now use the formula to look at some examples. In example 1 I'm having here, the question says, what is the quantity of heat required? What is the quantity of heat required? When I say quantity of heat required, that's example 1. Example 1. What is the quantity of heat required? That is H question mark. What is quantity of heat required to raise the temperature of 300 grams of aluminum cube? To raise the temperature of 300 grams of aluminum cube. So that 300 grams means the mass of aluminum M equal 300 grams of aluminum cube from 30 degrees Celsius to 70 degrees Celsius. From 30 degrees Celsius to 70 degrees Celsius. So which means initial temperature, that's theta 1, equal 30 degrees Celsius. And the final temperature, which is theta 2, equal 70 degrees Celsius. Then we are given that the specific heat capacity of aluminum is 900 joule per kilogram per Kelvin. The specific capacity of the aluminum is, that is, small letter c, equal 900 joule per kilogram per Kelvin. So these are the data given in the question, and we have to do what? We have to calculate the heat energy, that is, heat required to raise the temperature by particular value. Now, to go into that, from the formula, if you look at our formula here, we are looking for H. We have M in the equation, we have C in the equation, and we have theta in the equation. So the first formula here is suitable for the solution, that is H equal MC theta. I repeat, H equal MC theta. But there's something we need to take note here. Our M is given in gram. We need to take it to kilogram. That is, you divide it by 1000. That will be 0.3 kilogram. Our temperature is given in degrees Celsius. If you want to convert it to Kelvin, it still will be the same thing. If you convert each of them to Kelvin and you subtract, you still get the same answer. You get the same answer as when you leave it like this. So in order not to waste your time, you can leave it like this. But after the subtraction, your answer, the unit will remain Kelvin. So in that case, m h now equal m, which is what? 300 gram. Take it to kilogram, that will be 0.3 kg. The specific heat capacity is given as what? 900 joule per kilogram per Kelvin. So that is times 900. Then the change in temperature. Change in temperature means theta 2 minus theta 1. That's the meaning of change. That is the highest theta minus the lowest theta. The highest theta here is theta 2, which is 70, and the lowest is 30. So that will be bracket 70 minus 30. 0.3 times 900. 70 minus 30, that will be 40. Press of calculator, you multiply the 3 in the long run. By doing that, our answer will be 10,800. 10,800 joule. 10,800 joule. That is 10,800 joule of heat energy is supplied to the aluminium cube. So let's look at the solution from beginning to end before we go further to example 2. This is the formula. This is example 1. These are the data given. These are the data given. In the data here, you have H to be what? Question mark. That is what we are looking for. We have theta 1, that's initial temperature, to be 30 degrees Celsius. We have theta 2 to be 70 degrees Celsius. We have the C to be 900 joule per kilogram. And we have H equal MC theta. We substitute our value. And from there, we arrive at the answer. And our answer is 10,800 joule heat energy. So, let's move to example 2. In example 2, the question says, a copper rod with heat capacity 587 joule per Kelvin. A copper rod of heat capacity. Heat capacity means CP. CP here is 585 joule per Kelvin. Joule per Kelvin. Is heated on its temperature. On the temperature changes from 35 to 80 degrees Celsius. Temperature rises from theta 1 is 35 degrees Celsius and theta 2 is 80 degrees Celsius. From 35 degrees Celsius to 80 degrees Celsius. Calculate the quantity of heat supplied to the rod. Calculate the quantity of heat supplied, that is H. Calculate the quantity of heat, that is H, supplied to the body. If the specific heat capacity of the body is 390 joule per kilogram, C equal 390 joule per kilogram per Kelvin. This is the data given. I'm going to calculate H. For our formula as usual, H equal MC theta. But in this case, we don't have mass. As you can see, there's no mass. And also, we have theta, we have c. But in the question, we are given specific heat capacity. And we are given heat capacity. And from the formula, we are also told that Cp is same thing as what? Mc. Cp equal Mc. That is, heat capacity equal mass times specific heat capacity. So, which means here also, our formula here can also be Cp, then change in theta. Cp change in theta. Now, but the question we are asked to calculate, what we are asked to calculate, first of all, we need to determine two things, the H and the mass. From this particular one now, we can calculate our H. By doing so, our H will become Cp, which is given as what? 585. Multiplied by change in temperature. And the change in temperature, we are told the heat rises from what? 35 degrees Celsius to 80 degrees Celsius. So in that case, bracket 80 minus 35 degrees Celsius. That will be 585 times 80 minus 35. That should be, my calculator, 80 minus 35. That should be 45. Then 585 times 45. That will give us 263.25. 263.25. 263.25 joule. So the answer here will be 26,325 joule. Or you can take it to kilojoule. That will be 26.325 kilojoule. So let's go through this again. The data given, we are given its capacity to be this 583 joule per Kelvin. We are given the initial temperature to be 35. We are given the final temperature to be 80. We are to calculate the heat energy supplied. We are also to calculate the mass supplied, and we are also given the heat capacity, specific capacity of the body. Then our heat supplied is this. Now the other thing for we to calculate now is the mass, because we are also asked to determine the mass. So let's clean this side. Now, to calculate our mass, you can use this formula, H equal mc theta. This is m we are looking for. So let's make m the subject of the formula. By doing so, m will become H divided by c theta. M equal H over c theta. H is our value here, which is 26,325 divided by C. I will give you the C to be what? 390. 390. As you can see, 390 joule. 390 joule. Then that will be 390 joule. Then change in temperature, that will be what? 80 minus 35, which is 45. 45. We press our calculator, this divided by this, divided by this, then that will give us the final answer of our mass, which is given as 1.5 kilogram. 1.5 kilogram. 1.5 kilogram. So that is the end of the second example and also the end of part 2. inshallah, next class, we also go to part 3. In that part 3, we have to look at how we can determine the specific capacity of material. How many ways you can do that? There are 2 ways you can do it, either by elasticity or by method of mixture. Inshallah, next class we go into that. Thank you and God bless you. But in case of anything, if you have any question to ask me, you can contact me on my email kazenaaboo@gmail.com. kazenaabo@gmail.com. If you have any question or any comments, you can get me through this. Thank you very much, everybody, and please play safe and stay at home till the end of the pandemic. God bless you all.